We're going to talk more about planes and how we can find equations of planes given certain things or all kinds of stuff. So let's pretend we're given 3 points. And I'm asking you, given 3 points, find a plane. Now, the first thing you should probably try and do, if this is the first experience with a problem like this, is convince yourself that 3 points define a plane in 3 space. A little bit of thought, it's probably not that bad, right? So if we were to just think about the x, y, z axes for a minute in the 3 space that we defined, if we were to pick 2 points in space, just say these 2 points, we know for sure there'd be a line going through that. Okay? Now the question is, would there be one plane that goes through that line? And the answer is no, actually. You could put one plane through that line, and then imagine just tipping it slightly, sort of like tipping the top of a table. And you would end up with a bunch of planes, right, that are all at different angles to this line, but all contain this line. So 2 points in 3 space is not enough to guarantee you have one plane. If I pick a third point somewhere that's not on that line, so it's not collinear, then I'm sort of saying, hey, I've got to have that point as well. Well, there's only one plane that would go through that point and that line. So 3 points are enough to determine a unique plane in 3 space. Okay. So, yeah, let's give an actual example. So let's pretend I gave you 3 points, and we said, hey, here's the point 1, 1, 0. Point B is going to be 0, 0, 0. And point C is going to be negative 1, 1, 2. Okay, well, I'm not going to attempt to draw these correctly here. Well, I guess we could do that. Let's draw little axes here and attempt to get a sense of what this plane might look like. So here you go. Here's x, y, z. The point A is 1, 1, 0. So that would be forward 1 on the x-axis, forward 1 on the y-axis, and don't move at all on the z-axis. Okay, so there's your 1 point there. 1, 1, 0. Okay. 0, 0, 0 is right there. This is the point A, by the way. Here's the point B, 0, 0, 0. It's at the origin. And C is negative 1, 1, 2. Okay. So negative 1 in the x direction means I have to go back a little bit, that far. Forward 1 in the y direction means the shadow of the point would be right here. So I'll do that in green. The shadow of the point would be there. This is really the point negative 1, 1, 0. Kind of like to draw the shadow first. And then this 2 means we're going to go up 2 units from that in the z direction. So the real point we want is right here. Here's the point C, negative 1, 1, 2. Okay? All right, so now we have all our points labeled. Here's B, point 0, 0, 0. And if you were to think about it, right, you think about, ignore the shadow point. Here's that vector there. There's a vector here, right? And if you think about it, if you think about those 2 vectors like stretching on forever, then they would sort of span out a plane for us. So it makes sense that these 3 points determine a plane. All right, so I'd like to have some good names for this vector, for these vectors. I think you can name this vector something. A minus B is what you want to do, right? And that's because when we write subtraction of vectors, this vector, a good name for that would be C minus B. Okay? When you write subtraction of vectors, the vector, it's the point it's pointing at. Not subtracting vector, vector points. That's how you get the vector you want. All right, I might have shuffled some language there. Okay, so now what? Well, I know the equation of a plane in general looks like this. It's A times x minus x0 plus B times y minus y0 plus C times z minus z0 equals 0. So this is from the dot products, right? Where x0, y0, and z0, these things, are the coordinates of a point that go through the plane, or that the plane goes through. Now, I'm happy about that. I actually have 3 choices for there, right? I know 3 points that are on this plane, A, B, and C. I know all of these. So any one of those can go in for x0, y0, and z0. So I'd be on my way, right? So let's write that down. Let's pick point A, maybe. All right? So it would be x minus 1 plus b times y minus 1 plus c times z minus 0 is equal to 0. All right, so my plane's all right. I mean, it's getting there. I just don't have a normal vector to the plane, right? ABC is the vector that's normal to this plane. Well, that's okay. We can actually work that out, can't we? Right? Can't we? Because what do we know about cross products? Cross products yield a vector that's perpendicular to the two vectors you started with. So if I just find the cross product of vector c minus b and vector a minus b, that would be a normal vector to the plane. So in this example, we sort of luck out in a sense, because when we go to subtract these, right, to make the vector from b to a, if I do a minus b, since b is 0, 0, 0, it's just the coordinates of a. Okay, become the components. So what we have here is a minus b is equal to the vector 1, 1, 0, and c minus b is equal to the vector negative 1, 1, 2. Okay, so I just need a cross product of those things. So a minus b cross c minus b is going to equal the determinant of this matrix, I, j, k, and then 1, 1, 0, and negative 1, 1, 2. Alrighty, so we're actually ready. We can finish this. Here we go. I times its minor, 1, 0, 1, 2, minus j times its minor, 1, negative 1, 0, 2, plus k times its minor, 1, 1, negative 1, 1. All right, let's finish it off. So here we go. This is going to be 2 minus 0. We'll multiply those together and subtract the product of those. So 2 minus 0 is 2. That's going to be our first component of our vector. All right. And then here you're going to have 2 minus 0 again. Well, that 0 is very convenient now, isn't it? So that's going to be 2, but then it gets negated because of the negative in front of the j there. So it actually is negative 2, comma. And then lastly, you're going to have 1 times 1 is 1, minus negative 1 times 1. So it's 1 minus negative 1, which is also 2. And now you're basically set. You can write your equation you're playing, because this is your normal vector. So it's going to be 2 times x minus 1 plus 2 times y minus 1. I'm sorry, not plus 2, but minus 2. So that negative. Oop, wrote 2 of them. And then you're going to have 2 times z minus 0 equals 0. So this is a pretty way to use cross product and dot product together to get the equation of a plane given 3 points. Right? Combines very nicely these two ways we know how to multiply vectors.